In this lesson, we're going to look at another classification which we refer to as the chemical classification of matter. Remember that in our last class, we discussed about the physical classification of matter, where we described matter in different states, such as the gaseous state, the solid state, and the liquid state. Now, according to research, it's been found that matter consists of little particles, or we could say matter in its form is a constituent or is a combination of different particles. Remember, we said we defined matter as a substance that has what? Mass and occupies space. Occupying space actually gives it its characteristics of volume. So we could say matter is any substance that has mass and has volume. In the bid to describe further how matter is formed, scientists went into research and figured out that there are little particles which come together to form matter, different states of matter. Now, that brings us to our topic for today, which is elements, compounds, and mixtures. Now, before we go into the concept of elements, compounds, and mixtures, remember in our previous class where we discussed about the changes that matter can undergo. We vividly had descriptions for the different types of material we find in our environment. Now, remember we talked about the mass. They are having a form. It's due to the bonding between these particles, right? So little chunks of particles come together to give us a mass of what? Matter. Now, what are these particles? Scientists actually describe these particles to be atoms. We could see that the smallest or tiniest particles of matter are called atoms. Now, these atoms come together or combine together to give us larger types of substances, right? So looking at elements, it's simply the simplest or purest form of matter. That is, this particular substance contains just one type or one kind of matter. Remember when we talked about the homogeneous and the heterogeneous forms of matter? You could recall that homo simply means having the same kind of matter, while hetero, as the name implies, have different kinds of matter. What is an element? An element simply has or is that form of matter that constitutes of just one kind of matter. We could refer to it as a pure substance. Is the purest form of matter. So, having understood that an element is simply the purest form of matter, let's take for instance, we look at our appliances, our electrical appliances. There are terms which we use in different fields, right? So an electrician will tell you that the constituent of a motor or the constituent of a fan consists of certain little substances that they could fix together to make up the circuit or the rotor engine. So they call those things elements. So they are more like the concrete aspect of that particular substance. So in the same vein, we see elements as the concrete or the purest form of a substance. Now, Like I said earlier, these elements have or could be described in terms of atoms. These atoms are little particles that come together by virtue of going into a reaction, right? Elements could be represented in what we call chemical symbols since they need a very accurate description. For instance, elements such as oxygen. Remember that we need oxygen for life. Oxygen practically supports every form of life, down to plants, animals, and even humans. In the bid to describe what this element oxygen is, scientists had to come up with chemical symbols, and then oxygen is represented as O. This O could be referred to as an atom of oxygen. Now, when two atoms come together, remember I said there must be a reaction, and these reactions involve either the sharing of electrons, the gain, or the loss of electrons. Basically, atoms go into reactions, right? Now, if I have O to represent oxygen, we will say this is the chemical symbol for oxygen, which is an element. When I have one atom of oxygen reacting with another atom of oxygen, this gives me, you can see this is 1 and this is 2. This gives me O with a subscript of 2. We call this an oxygen molecule. We are trying to establish a fact of how matter came about, what comprises matter. So, looking at this explanation, every matter or every piece of substance boils down to atoms, which are the tiniest or simplest form of any matter. So now, other examples of elements such as carbon, we have nitrogen, we have hydrogen, we have argon, sulfur, and a host of many others. Now, in the bid of this research, during studies, it was figured out that we had about 118 elements. Yes, 118 elements. So practically the whole of matter, the universe, and everything evolved from the reaction of either atoms of the same element or atoms of different elements to give us these things we have in our environment. Now, if we know that atoms react, either atoms of same elements or atoms of different elements, so anything we find in nature simply stems from these tiniest particles, atom. Now, I said there are about 118 elements, right? But some of these elements can be sourced naturally from our environment. Yes, it was discovered that almost every living organism contains carbon. Yes, carbon, which is an element, could be found in living tissues, could be found in plants, could be found in animals, and a lot of substances we use in our homes. So carbon is also an example of an element. Now, having understood what elements are, looking at the next concept, compound and mixtures. So if atoms will have to go into reactions, what do they do, or what do they give rise to? What's the result or after effects of atoms going into reaction with either atoms of same elements or atoms of different elements? Now, when these atoms go into reaction, they give rise to other things, or could say other substances, other forms of matter, which we could classify as compounds. So compounds is simply a combination of what? One or more than one element, one or two elements. So when the atoms of, let's say, for instance, we have our salt, right? Our common salt, which is sodium chloride. Our common salt is formed basically from two elements. We have sodium and then we have chlorine atom. So this is sodium atom and this is chlorine atom taking part in the reaction. But you still remember that sodium is an element, right? So what takes part in the reaction is those individual particles which we refer to as atoms. Now, remember I said these compounds are formed from what? Combination of what? Elements, right? How do they do this? Of course, their atoms go into reaction. Now, these elements, like you could see, sodium and chlorine, they are both elements. We don't have an element and something else, right? Remember, homogeneous mixtures contains one type or one kind of matter. An element combining with an element gives us a compound. So if we have the same kind of matter, it's simply a homogeneous mixture, right? So compounds are homogeneous mixtures. Now I would like us to take another example. Let's take, for instance, water. Water is odorless, colorless, tasteless, right? Liquid. So we have water. Now, water is formed from two elements, or I'll preferably say the atoms of two elements. So we have represented as H2O, right? So simply we're having two elements which are hydrogen and then we have oxygen. So we'll take water as another example. Yes, I know we'll be familiar with what or the compound water, right? Why do I call it a compound? Because it contains elements. Let's see that. Now we have that the chemical formula for water is H2O, right? So here you could see the elements hydrogen and oxygen. But do you discover that there's actually we have a subscript 2? So this means that we have two atoms of the element hydrogen reacting with one atom of the element oxygen. Remember when I said when two atoms come together, they form a molecule. But in this sense, this is hydrogen, right? Two atoms of hydrogen combining with one atom of oxygen to give us water. So this is simply a compound, but they are in a ratio. What do I mean? Remember I mentioned two atoms of hydrogen, and here we have one atom of what? Oxygen. So you could visibly see that water, a compound, consists of two elements which are in definite proportion by mass. What do I mean by definite? We could see that there's a number here to actually quantify or give measurements to the amount of hydrogen. We could say we have more hydrogen atoms than we have oxygen atoms. Yes, so that is one of the characteristics of a compound. Now, remember I said these compounds are made from combination of elements, right? Now, and if you could remember, I talked about these concepts being under the chemical classification. This chemical classification is as a result of the chemical process that occurs, which could not be seen visibly with the human eyes. So what happens where atoms of hydrogen elements and atoms of oxygen come together to form water? We can't visibly see what goes on there. So in a bid to explain how this combination is done, scientists actually discovered that there is a chemical bond binding the atoms of these two different elements, right? So we take, for instance, as we used earlier, the compound water. So we could say that water is a combination of the atoms of hydrogen and oxygen. Now take a look at this. You see that there's a bond holding or joining the atoms of oxygen to the atoms of hydrogen. So every compound has a chemical bond or elements of a compound are chemically joined together. We have that there's a chemical bond that helps them stay together as a compound. If these elements are held together to maintain their state as a compound, does it mean they can actually be separated since they combined? Could they be separated? Yes, of course. Water can be split into its individual constituents, but by a chemical means, because it was actually combined by a chemical process. So separation must be by a chemical means. When I discussed about homogeneous and heterogeneous substances, yes, we could say that a compound is a homogeneous substance because simply it consists of same kind of matter, which is elements. Now, in the case of a compound, in the combination of the atoms of these elements, you find out that there's actually an evolution of heat, or you'd say energy. So this energy could come in form of heat and any other form of energy. While these atoms, remember, we cannot visibly see with our naked eyes what goes on in the process, in this chemical process. During this combination, you see that energy is either used up or given off. Now, remember I talked about how compounds are formed from a definite proportion by mass of these elements. And then I used a chemical formula to represent compound. Do you know that sand is also a compound? That means it could be represented using a chemical formula. Yes, the sand we see simply consists of the elements we call silicon, and two atoms of oxygen. We have that the chemical formula for sand is what? Combination of silicon and oxygen. There are several other substances we could find in our environment that could be represented using a chemical formula which automatically makes them compounds. We have chalk, we have sugar, we have quite a whole lot of them. And now, having understood the concept of compounds, what are mixtures and why do they differ from compounds? Can I invariably use the same term for mixtures and compounds? Let's take for instance a bowl containing chalk and water. Now, you could see that if that particular substance is left, particles like dirt and other things could be part of that substance. In a bit to describe what a mixture is, it was figured out that mixtures contains constituents that are, in this case, physically bound together. What do I mean? I can take a cup of water and a cup of rice, and I can just pour the cup of water into the rice. That's simply a mixture of rice and water. But remember, in the compounds, you cannot physically say you take atoms of hydrogen and mix up with atoms of oxygen. So that is a chemical process. So while we have that mixtures contains constituents are physically bound together. For instance, paint. You look at the substance paint, you discover that, especially when it comes to some kind of paint, leaving them for a very long time, you figure out that the denser part actually settles down, leaving a different layer of material at the upper part. Now, you could also see visibly particles that come together to form that paint, or we could say they are materials that were used in making the paint. Okay, so I would like to use another example. For instance, our cake. You have a mixture of flour, baking powder, sugar, butter, and a host of them. Take a piece of cake and look at the layers very closely. You will discover that they are distinct form, but it doesn't really give us a homogeneous mixture. If we have mixtures of flavor, you will definitely tell that there's a difference in the constituents of this particular substance. Now, these constituents are joined or combined by a physical means, so we call them what? Mixtures. If they are combined by a physical means, invariably they can be separated by a physical means. If I have a mixture of rice and beans, I can easily pick out my beans, leaving my rice. So you see that these mixtures, or whatever should be classified as a mixture, should be separated by a physical means. Another property or characteristics of mixtures, or feature that we could use to identify vividly that this is a mixture, is that these mixtures, since they are not in definite proportion, right? You could have any amount of certain substances mixing together, any amount. So we do not have a definite proportion for these mixtures. Now, because we do not have a definite proportion by mass, they cannot be represented in chemical formulas. We don't really know for sure what exactly these mixtures contain when it comes to atoms of elements. They cannot be represented by chemical formulas. So remember when I talked about compounds, I explained where in the process of getting into reactions, that's when atoms of elements go into reaction, there's usually an exchange of energy in form of heat. It could either be a release or it could be a gain of this, an absorption of this energy. But in mixtures, you don't really have any exchange per se in when it comes to the use of energy. There's practically almost no change in energy. So there's no absorption and there's no release of energy. So we could say that these mixtures can be combined without involving any energy change. Now, having described what an element is and giving examples, relatable examples of what elements are, and how compounds as well as mixtures can be formed and identified, we'll take a look at the process of separating these compounds or these mixtures. We said compounds are formed from constituents. So how do we separate these constituents? How do we separate mixtures into its individual components? Before we go into that aspect, I would like us to remember that these constituents have their individual properties. Now, the constituents of a mixture give the mixture its property. So if I have a mixture of A, B, C, D, and E, that mixture attains or takes the property of the sum of these individual mixtures. So it must have the property of A, it must have the property of B, it must have the property of C, and it must have the property of what? D. So if A, B, C, and D combine together to give me a mixture, my mixture will have a property of A, B, C, D. Every mixture has its property as the sum total of the individual properties of the constituents. But this is not the same for compounds, because when the atoms of these elements go into reaction, an entirely new substance is formed, which we refer to as a chemical change, where an entirely new substance is formed. And that means the properties of that substance automatically changes. So you can't say that sodium chloride has same property of sodium, or neither could you say that sodium chloride has the properties of chlorine. Sodium chloride definitely has a different property from the individual constituents. Now that I've been able to give an expository on what elements, compounds, and mixtures are, I believe you wouldn't get confused as we go further in chemistry, when we need to look at atoms of elements going into diverse kinds of reactions. Remember, chemistry is basically the study of matter, its states, properties, changes, and the transformations it undergoes. And I told you earlier that modifications of products came as a result of different or series reactions that atoms of different elements had taken place. In our next class, we're going to look at how these mixtures can be separated into their individual components because they're actually physically combined together, so they can be separated by physical means. If you have any questions as regarding this particular lesson, you could kindly drop those questions or comment in the comment box. See you in the next class.